Hey guys, first of all, sorry, I thought I would have this up way sooner, so hopefully you'll get a chance to see it before you get back from spring break. I'm not going to put a homework assignment with this particular video until you guys get back. The Monday following spring break, when we're back, what is that, April 1st, I believe, I'm going to have an in-class assignment that we're going to do to go with this video. So first of all, I want to talk about what we're doing. We're finding area underneath curves right now. I haven't really presented essentially what we're doing, or the method we're using. The method we used in the last couple of videos was finding area with vertical rectangles. If you think about when we very first started talking about integration, we started by looking at rectangles and about how if we looked at a couple rectangles, we could use that to approximate area under curve. And then we expanded to say, hey, what if we turn that into a limit and said there were an infinite amount of rectangles? Then we could use that to get the actual area under our curve. So if we're kind of still using that same idea, notice I have two pictures of the exact same curve here. I'm going to show you one way to do it with vertical rectangles, and then a way to do it with horizontal rectangles, and the difference in terms of what you're finding. And then we're going to look at a second example that can really only be done with horizontal rectangles, or I guess it could be done with vertical rectangles, but it's much easier to do it with horizontal rectangles. So that being said, I'm going to go ahead and say, what if I wanted to find the area between f of x equals x squared and between g of x equals 0? So basically between this line here. I'm off a little bit, sorry about that. So what I'm doing, and what we've been doing, is we said we just take top curve minus bottom curve, and then we integrate. Well, I'm going to use that same idea, and I'm going to tell you that I want my x values to go from x equals 0 up to x equals 4, and I'm going to find the area underneath this curve. Doing that, I don't know why it looks like my iPad's off a little bit here. I'm not lining up very well with my lines. Doing that, if I chose rectangles, so let's say I went up to my curve, came over, and then came back down. So the height of my rectangle would be f of x. The width of my rectangle, call it dx, and then f of x times dx would give me my area of that rectangle. So if I turn that into an integral, how do I find the area from x equals 0 to x equals 4? Well, all I do is say the integral from 0 to 4, x squared dx. I can go ahead and I can enter that into my calculator, or I can integrate it myself. Either way, I get 64 thirds. That would be using that vertical rectangle. This 64 thirds represents the area between these two curves and between x equals 0 and x equals 4. So all of this in here. What if I wanted to look at horizontal rectangles? So if I'm going horizontal, same idea. I'm going to go ahead and then this time I'm going to start on the y-axis. So look at what I did when I started at the x-axis. I had some x equals and some x equals. I'm going to do the same thing. I'm going to say I'm going to have some y value down here, which I know, I'll just do this, and I'm going to have some y value up here. Okay. And then I can say, what is the area between this line here? So instead of y equals 0, I have the line x equals 0 here, and then of course my curve y equals x squared. If I'm finding it, so I'm finding this area here because I'm now using horizontal rectangles, and I kind of missed my curve. Again, I don't know why I'm so off. I'm using horizontal rectangles instead. So how am I going to do this? Well, I'm going to go ahead and I'm still finding area, so I'm going to use an integral, but the difference is now going to be that I'm going to have y equals something up to y equals something, and instead of having some f of x function, I'm going to have some f of y function dy, because kind of using that same concept that this width is going to be dy, this height is going to be some f of y. So my integral will look something like this instead. So if I look at what I'm going to do, the very first thing I'm going to do is I'm going to go ahead and find f of y, which basically means instead of solving for y, I'm going to solve for x. Well, my function is y equals x squared. If I were to solve this for x, I would have x equals the square root of y. Okay, so that's my function that I'm going to integrate. The next thing I have to do is I have to find my points of intersection. I was already told before that this is happening when x is 0 and x is 4. So I'm going to use those same ideas that I know x is 0 and x is 4. So I'm going to go ahead and plug x equals 4 into my function here, and I'm going to plug x equals 0 into my function here because I still have that basic, or that, excuse me, that x value of 4. So then from there, that gives me when x is 0, y equals 0 squared, or 0. When x is 4, y equals 4 squared, or 16. So those are my points of intersection. And then for step 3, I'm going to go ahead and solve. So setting up my integral to solve, I'm really out of room here. I'm going to swing it way up here. And my integral is going to go from y equals 0 up to y equals 16. The square root of y dy. From here I can either integrate or I can put it into my calculator. If I put it into my calculator, I get 128 over 3. And notice that I do get different answers, but remember the difference is, am I finding the area under the curve here, or am I finding the area between these two curves here? So it's about where I'm asking for which area I'm looking for, I guess. Let's look at the second example. Suppose I were asked to find this area in here. Okay, that's the area I'm going to be asked to find. So let's say I go ahead and I say, well, I'm just going to go ahead and use my vertical method. Well, using my vertical squares, I noticed that I could do a rectangle here. Okay, and then I would have top curve minus bottom curve. The top curve being the y squared over 2 minus 3, since I know that that's going to be my first function. This is going to be my straight line, will be my second function. And I can put another vertical rectangle here, and here are my 2 points of intersection. And notice that I can continue doing vertical rectangles, and I'm going to get that area. But in terms of finding top curve minus bottom curve, I run into an issue right here, because now all of a sudden my bottom curve is no longer part of that x minus 1. So if I wanted to use vertical rectangles, the issue that I run into when I do top minus bottom is my bottom changes. Okay, so I would have to do more than one integral. So I could fix that by instead doing horizontal rectangles, because notice if I do a horizontal rectangle, I don't run into that same issue. I always have a right function and a left function. When I'm doing horizontal rectangles, I didn't really touch on it in the last example, mainly because one of my functions was x equals 0. But what I'm doing now, so when I have vertical, I do top minus bottom. When I do horizontal, I'm always going to do the integral of right minus left. And so my right function is always y equals x minus 1. And notice that my left function is always x equals y squared over 2 minus 3. So if I kind of use the same steps as before, my step 1 is I have to figure out my f of y. So I have to get I have to get x by itself. A little bit different thinking than before. Well, notice that my first function, f of y, is already by itself. F of y I can say is y squared over 2 minus 3. If I look at my other function, this one right here, y equals x minus 1, I can add 1 to both sides, and I'd say I call that g of y is just going to be y plus 1. Okay, I can leave it as x equals, it doesn't really matter. And then the next thing I have to do is I have to find my points of intersection. So if you remember from before, I can do that by setting my two equations equal to each other. So my two equations are right here, because notice that I always want to get x by itself first, so that when I set my equations equal to each other, I can solve for y. Because if I'm integrating with a horizontal rectangle as opposed to a vertical rectangle, I have to have my lower and my upper limits in terms of y. So I'm going to go ahead and say, when does y squared over 2 minus 3 equal y plus 1? So I can go ahead and I can multiply everything by 2 so I don't have that denominator, and have y squared minus 6 equals 2y plus 2. I realize that this is quadratic, so I'm going to move everything over with y squared, and I would have y squared minus 2y minus 8 equals 0. I can use a factor sum table and get y minus 4, y plus 2. So I get y equals 4 and y equals negative 2. So now from there, I have my two equations. I know which is on the right, I know which is on the left. I'm going to use y equals 4 and y equals negative 2 as my limits, and I'm going to go ahead and use my calculator to integrate. So I'll have the integral from negative 2 up to 4. My right function, which was y plus 1, minus my left function, which was y squared over 2 minus 3. I'm going to integrate with respect to y. I'll go ahead and put this in my calculator. When I do, I'm still going to put it in terms of x in my calculator. And I punch it all in, and my calculator tells me that this gives me 18. Okay. So the big thing is when you look at the area that they're asking you to find, you want to ask yourself, is it going to be easier to use horizontal or is it going to be easier to use vertical rectangles? Generally speaking, if you change between top and bottom functions, you want to go with horizontal limits. Or if you're, well, I guess I'll get into that more in volume. So I would say that if you change top to bottom, it is usually easier to do horizontal. Another thing to look for with the difference between horizontal and vertical, sometimes you'll think that vertical is going to be easier and realize you have to set up multiple integrals. And that also might be a clue that horizontal may be easier because you may only have to set up one integral with horizontal. Like I said, when you guys get back from spring break, we'll do a worksheet on this in class.